Okay, this is a video lesson over section 7.4, adding and subtracting rational expressions. We have a difference in this problem of two rational expressions. Remember, rationals are fractions. So we have a difference of two fractions, and we need to combine these two fractions together. And basically the same process that we learned back in grade school on how to add and subtract fractions with different denominators. Remember, in order to subtract two fractions, the denominators must be the same. We must have a common denominator. Specifically, we want a least common denominator. Now, how do we do it in the case of algebra? To get a least common denominator, what we do here is we have to factor each of these expressions to find the least common denominator. So we need to factor these. Okay, remember when we factor, you first look for greatest common factors and take those out. And in this case, we do have greatest common factors in each of these. So if you look at this first one, 5x squared minus 5x, we have a common factor of 5x. And we're going to take a 5x out. Now, when we take 5x out, what is left over? Well, 5x to the second divided by 5x leaves us with x minus 5x divided by 5x is 1. So that's the factor denominator in this one. You do the same thing here. I think you can notice that there's a common factor here as well. It's 5. So we're going to take a 5 out, and we're left with x minus 1. Okay. So now, once we factored the two denominators, we come up with the LCD. Okay. The LCD is gotten by listing every single factor you see the most times we see it. So what I'm going to do here is I'm going to make a little table. Factor and like the number of times we see it. Okay. So if you notice here, we see a 5 as a factor, and the most times we see 5 is once. Now, yes, we see 5 twice here and here, but we only see it a grand total of one time in each one, so we only need it once in the LCD. Another factor is this x. So we have x, that is seen once, and we have an x minus 1. See, the parentheses are important because the parentheses show that this is one complete factor. So we see x minus 1, and it appears once here and once here, so you only see it once in any given one fraction. You see it once. So our LCD is going to be 1, 5, 1x, and the x minus 1. So what we need to do is we need now make new fractions with 5x times x minus 1. Okay? And now we need to come up with our equivalent fractions. Okay. Now, if you notice, we need 5x times x minus 1. Our original fraction in the denominator did have 5x times x minus 1. This here is the same as this. Okay, and since they're the same, the numerator won't change, and that still stays as 8. Okay, this one changes a little bit. All right, in order to get 5x times x minus 1, notice in this fraction we have the 5 and we have the x minus 1. We're missing the x. So what we need to do is we need to multiply this one by x to make it equal to this, which means if we multiply the bottom by x, we have to multiply the top by x. And that gives us 10x now. Okay, so now we have 8 over 5x times x minus 1 minus 10x over 5x times x minus 1. So now we can put these together. So the numerator is 8 minus 10x, and the denominator is 5x times x minus 1. And now what you look to see if you can do is is there something that can be canceled here? You can't cancel this x and this x because this x here is being involved in subtraction. You can't cancel this 10 and this 5 right now because this 10 is involved in subtraction. You can only cancel parts that are only solely being multiplied. Okay, so what we're going to do is we're going to factor this numerator. If you see that there is a 2 common in both of these terms here, 8 divided by 2 is 4, minus 10 divided by 2 is 5, and that leaves us this over 5x times x minus 1. Now if you notice here, now we can cancel this 2 here. We can cancel this 2 here because it's only being multiplied, but there's nothing to cancel it with. 2 can't cancel with 5. 2 can't cancel with x. These two can't cancel with anything because they're being subtracted. You can either cancel the whole parenthesis or none of it. Okay, so it looks like this is going to be our final answer. Check out links to Khan Academy. There are other examples of adding and subtracting adding and subtracting rational expressions. And then in the next section, in 7.6, we're going to show how to solve rational functions. Thank you.